Easily find the angle between two lines using this equation. You know that you know trigonometry, yes? If you know, that would be very easy to find that. So, and the last, take a look at the take a look at these three deflections. Here, the net deflection in this QRS complex. The net deflection here is positive. Here, negative. Here, the net deflection, positive deflection are equal to each other. Means if you sum them up, you will have 0. If this situation is met in one of limb leads, that lead is called equiphasic lead. In that case, if you have this situation, take a look at this example. Take a look at this. In ADR, lady, in ADR, take a look at the ADR. Take a look at the ADR. The net deflection is 0. Am I right? It means that AVR is equiphasic here. So if you have an equiphasic deflection in any limb leads, 1, 2, 3, AVR, AVL, and AVF, then the cardiac axis in that ECG, in that person, is perpendicular to the axis of that lead. Means here the cardiac axis. When I was a PhD student, I had a classmate. He was trying to ask a question to our instructor, and while he was asking the Nos, you wrote in Arabic? Nos. It's perpendicular to the axis of AVR here in this example. How much is the AVR axis? How much is the AVR axis? 0. 210 or minus 150. The picture I showed you. 30 plus 180 equals to 210. So the axis is perpendicular to 210. Means the axis equals to 210 plus minus 90. So you may have two axes. One 300 and the other one 30. So supposedly you have two axes. One 300 or minus 60 or 30 degrees. Which one is correct? Did you get? No. Take a look. 1, 0 degree, 2, 60, 3, 120, halfway, that would be from the negative direction. That would be minus 30. That would be 90. That would be 210. So, if you want to make two perpendicular lines to ABR, this is one line and this is one line. Am I right? Means 210 plus minus 90. 30, 300 and 120. Am I right? So you have two you can have two perpendicular lines. 300 equals to minus 60. Am I right? Okay. If you want to see which one of these two choices are correct, then you should go to the nearest axes to minus 60. Which one nearest to minus 60? AVL, because AVL equals to minus 30. If AVL is the correct answer, you should have the biggest positive AVL deflection. Take a look at AVL. Since AVL is positive, I mean the net deflection in AVL is positive, then the answer would be minus 60. If 120 is the correct answer, then nearest to 120 is limit 3. Am I right? So if 120 is the correct answer, you should have the biggest positive QRS complex in limit 3. Since the net deflection in limit 3 is negative, so that wouldn't be the right answer. The right answer is minus 60. Means this part is actually deviated to the left. This is called left axis deviation. We have discussed it in classroom. In which situation do we have left axis deviation? Hypertension, aortic valve stenosis, or regurgitation? Did you get? Now let us make some examples. First, tell us the heart rate here in this area. Is it difficult to? The heart rate. Take a look at your notes. You should find two subsequent. You should find the rhythmicity. Means the time gap between two subsequent QRS complexes equal to each other or not. So the time gap are equal. So if it is equal, then you should divide 60 over the time gap between two subsequent QRS. 4, 10, 14, 1, 15. 15 times 0.04 equals to 60. 60 over 60 equals 100.
60 over 60.
60 divided what?
See, how many S1 squares do we have?
Sorry, can you repeat it?
3, 5, 10, 14, 15. 15 times 0.04. How much would be?
0.6.
0.6. 60 over 6 equals to 0.06. 60 over 0.6 equals to 100.
Yes.
Equals to 100. Am I right? So this is the heart rate. The first. The second, we want to see if the rhythm is normal or not. So what should we do? 5 rules. First, in order to have the best P wave, you should refer to limit 2. Before each QRS complex, take a look. Before each QRS complex, you have a P value. The gap between subsequent QRS complexes are equal. The heart rate is between 60 up to 100. Here is 100. P should be positive in LV2 and negative in AVR. So the rhythm is normal. This is normal sinus rhythm. And her question. Here, as you can see, the positive and negative deflection are equal in LV3. You have an equiphasic lead in LV3. Means the cardiac axis in this sample is perpendicular to LV3. How much is LV3 axis? 120. 120. 1 is 0, 2 is 60, 3 is 120. You should make two perpendicular lines to 120. Means 120 plus minus 90. 120 plus minus 90. Means 210 and 30. Is 210 is the correct answer, then you should have the biggest, am I right? The biggest QRS complex in AVR. This is AVR. If plus 30 is the correct answer, means in limit 1 or limit 2, which is near to plus 30, then you should have the biggest positive QRS complex in limit 2 or 1. In both limit 1 and 2, the deflection, the net deflection is negative. So the correct answer is 210. Means you have the right axis deviation. Did you get it? That lady. Ask her to come. She is the same. Near to you. The lady who has worn black veil. Come to the board. Yes, near to her. Come to the board. No, that one. Who wears glasses?
It's a bit long.
Yes.
No?
Tell us how much is the rate in this? How much is the rate?
Which one?
See, in order to find the heart rate, first we should check the time gap between subsequent QRS are equal to each other. Is that equal to each other? Yes? Yes. Time gap are equal. So if the time gap is equal, then what should we do?
Small boxes.
Now, come closer please.
The small boxes.
How many small boxes can we calculate here between these two sources? How many small screws do we have here? 5, 10, 15, 20, 21. Am I right? 1,500 over 25, 21. How many? Around?
71.
71, 72 or something. Is that correct? Is that clear? So, 1,500 over the number of small squares between two subsequent ones. 1,500 over 21 equals to 71.
Why 1,500?
Why?
There's two ways. Either 60,
No. No. Come to the board. Thank you.
No,